All right, so I'm gonna get started. Please turn your phones off.
Thank you.
Whoever's phone was just ringing. So this talk is called Adventures in Dunderland, the Python data model for Perl Mongers. It's kind of a mouthful. I'll talk about why it's called that, later on when I get to it. So I want to start with a little bit about my background. If you've been coming to my talks here at YAPC for the past few years, I gave a talk about COBOL a couple of years ago, and actually last year too. Last year, I also gave a talk about punch cards, which a lot of people liked. But I've tried not to just talk about stuff like that's sort of way in the past, although that's kind of cool. Like I love Perl as well. I have this weird background. I have a PhD in computer science. And so I have this list. So I like things other than Perl too, as you can tell from the things I was talking about before. So this is a list of all the languages I've worked on since I had my PhD defense in 2012. I'm probably missing some things there. But I would also think that since probably all of us are in the same situation. I mean, maybe it's great if we can work on Perl all the time, but lots of us are kind of in an environment where there's lots of different languages, right? Like someone's working Perl, maybe you're doing JavaScript, maybe you're not doing COBOL, but there's some Java, there's all kinds of languages in your shop that you might have to work with, right? Or lots of us might be interested in learning some different languages as well. That's why I was kind of learning Swift and R and things like that. I had been in academia for about a decade, and then last year I found myself working at an internet startup. I never made it out to the California office. I think my impression was it was kind of like that. And then one of the things about this job was that it was a Python shop, and I felt I was probably at the stage where you were, where I was sort of dabbling with it, but I had gone through all of the advent of code problems for the previous year. I did them all in Perl and in Python, both in Python 2 and in Python 3. So I was feeling, which pretty much was just whether the print statement had parentheses around it or not. And I was thinking, I thought I knew it pretty well. At least well enough, I figured I would learn some stuff on the job, but I thought I knew it pretty well, right? And it's not really all that different from Perl and C++ and Java, which I knew a lot better. And we're all kind of like that, right? Like the way we can learn all these languages is that there's a lot of similarities between them, right? Like you're like, oh, how do I make an object? How do I do a for loop? Yada, 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 right? But as we know from this is, of course, one of America's foremost philosophers, Donald Rumsfeld. He has this famous quote about known knowns and unknown knowns and whatever. And it's really, as he says, it's like the unknown knowns, the ones we don't know about. Those are the ones that are really going to catch you. There's actually a term for this I learned called hypocognition, and that's the lack of a linguistic or cognitive representation for an object, category, or idea. So that's kind of a big mouthful. What does that mean? I think there actually is a talk that's kind of all about this later on today. A good sense of this is in Russian. So in English, we have one word for blue. In Russian, they have two words for blue. They have a word for dark blue and a word for light blue. So we have two words for red. We have light red, which is pink, and we have red, which we call red. So there have been studies that show that people who are native Russian speakers can differentiate between different shades of blue better than native English speakers, because they just have that sense in their head that if it's got a different word for it, it's something you need to pay attention to it more. And as I said, so while we have all these languages and they have a lot of similarities, it's really like if a language has, knowing that there's a lot of similarities can get you a certain way along the road to learning the language, but it's really the things that are unique to the different languages that can really trip you up, and especially if they're not in a language that you're already familiar with, because you won't even be looking for that feature to be in the language. So I don't know why I had these all. So when I got to this job, so there was Python, which I figured I already knew pretty well. But we have this whole stack of other things. So if you ever get a job in a Python shop, especially one we were doing microservice development, there's this whole long stack of things. And I honestly can't tell you, some of these I know, but where Flask ends and Swagger begins, it's kind of a mess. I mean, it's kind of like a good mess where when it all sort of works, it's kind of magical and you don't really have to know where it is. But there's a bunch of things. One problem is that because we're doing microservices and because it's already, let me go back here, I shouldn't. Right. So we had everything running in Docker already when we were doing development. So it's already in like one shell. And then Flask puts another shell kind of around it. And it's in microservices, and the only really good way to communicate with it is to either send requests to it and then print things out to the HTTP log. There's other ways to do it, but that was the simplest way. So just kind of keep that in your mind as like what the problem was, because the problem is like how do you go and debug it, because there's all these layers around it. So I have this slide where I have a bunch of caveats on here. And this is because the first time I gave this talk, there were a bunch of people who actually did have experience with all those things that were on that slide. And they also were Python 2 programmers. So they started asking me all these questions I didn't know the answer to. So I decided I would put up this slide with a bunch of caveats. One is that all the code I'm going to show you is in Python 3. It's not in Python 2. I don't really know Python 2 as well. So I wrote this about a year ago that I'm still learning the Python REPL. I still kind of am learning the Python REPL because it was hard even to get to the REPL from the way we were developing things. I know there's all kinds of tricks about things that I'm still kind of learning. If you're familiar with these tools, there are probably better ways to do what I'm showing you, but ultimately it's a talk about the Python data model and not a talk about debugging Flask microservices. This is what people wanted to turn my talk into the first time I gave it. Like, you're not debugging this the right way. You should go into Flask. I'm like, okay, fine. So one day I came across this problem, and I want to recreate it here. So let's say we have a table, and I know I have to apologize. Well, there's no Python people here. I know it's traditional. You have to have some Monty Python references, but that's not what I'm going to have here. So this was actually when I was doing this biomarkers, but let's just say it's something simple with animals and how many legs they have. And this is the table that I have with 6 animals and how many legs they are. I know some starfish have more than 5 legs, but well, we'll say most of them have 5 legs. Okay, so it's pretty straightforward, right? We've all seen these things 1,000 times. So in Python, we were using a tool called SQL Alchemy. And SQL Alchemy, looking at it from a Perl perspective, is kind of a combination of DBI and DBI X class, meaning that you can either write plain SQL or you can sort of make a whole model and get at it from the ORM. So what this is going to do is that the SQL is at the top. It's going to execute the SQL, fetch all the rows, and then print them out. All right? And when you do that, this is what it prints out. So I should point out, in Python, they have 2 different kinds of arrays. They have lists and tuples. Yes. Sorry?
Stay on mic.
Oh.
Otherwise, you're not being recorded.
Sorry about that. So let me repeat that. In Python, so when you run that command, it prints out. Does this come out? Anyway, we'll just leave that there. There's 2 different kinds of lists. There are arrays. There are lists and tuples. The differences aren't all that important here, except for here, tuples have parentheses around them, and lists have square brackets around them. So that is a list of tuples, and every one of the tuples is one of the rows that got pulled out. So the first one is the owl, and then the spider, and the ant, and so on. All right? So what I want to do is turn this into JSON, because we're writing microservices and we have to output JSON to the thing that's calling us. Now, JSON, so I should say that Python actually has some really good tools for dealing with JSON. In fact, JSON looks like Python dictionaries. Dictionaries are what Python calls hashes, except you don't have to worry about, like in Perl with references and things like that, there's no references. So if you look at a at JSON and you look at the Python like dictionary representation of it, it looks almost exactly the same. So it's really easy to go back and forth with them. But JSON, of course, is like all key value pairs. All I had there were values. So I want a dictionary. I want to have a dictionary because dictionaries and JSON are almost the same. Now, if I were writing Perl, I could do in DBI, I could do something like fetch row #ref, and that's going to give me the keys and the values. But again, all I have here are the values. I don't have the keys that go along with it. So I was really sad. I didn't know how to deal with that. So I ended up writing this, which is kind of a mess. But when I did that, I got that back. And like, okay, there are my keys. There are my values. So Larry's taught us about how important hubris is in writing code, right? And I was feeling pretty smug when I wrote this because, okay, let's step through this. So because I wasn't getting the keys back, I hardwired the keys that I was getting. And then zip, what zip does is it goes through, so the first parameter is the columns, the second column is the rows. So it's going to pair up the first column and the first thing in the columns and the first thing in the row, and then the second thing in the column and the second thing in the row, and the third thing in the column and the third thing in the row. So it's going to make tuples of the keys and the values, squash them all together, and then, so first of all, I was really happy about this because I knew about zip. I know about zip for about a decade. I never had a reason to use it. Finally, I had a reason to use it. I was really psyched about this. And then Python has these things called comprehensions. They have list comprehensions, which are kind of their version of map. This is even different. This is a dictionary comprehension. So this is kind of like a map, but it's going to turn it into a dictionary instead of into a list. And so that's the syntax for that. And so I was pretty psyched about this because I'm still kind of learning Python. I'm learning the ins and outs of it. So I put this together. I'm like, finally, I figured out how to do this. I should say, because there's an ORM, we had examples in the code of using the ORM thing because that already has the whole object model, and every example I saw was using that. And I thought that was the only way you could do it. So I wrote code like this. I did the pull request. And one of my teammates said, you know, that's really cool, Walt, but why didn't you just call dict? Like, huh? So dict is the constructor for dictionaries. So I went through the documentation, and there's a lot of ways to make dictionaries, right? You can make an empty dictionary like this, 2 different ways to make empty dictionaries. There's a whole bunch of different ways to construct them. You can actually give the named parameters, and it'll figure that all out. If you're ever looking through Python's documentation and you see something that says kwarg, that's what it means. It means you can do something like this. I don't know why anyone would ever do that, but you can. This is the sort of normal way that people construct dictionaries. You can construct it from tuples, which is more or less what that zip command was doing. You can zip it together like that. You can construct a dict from another dict. You can just assign them, but like none of them are doing that. I was going to say, people who say there's only one way to do it in Python, there's a lot of ways to make dictionaries, which kind of makes sense because you want to be able to make them in different ways for different positions, different situations. Again, none of these have keys. All of them just have the values. And none of these were telling me how to get the keys. So in desperation, I said, let me just take these lists of tuples and call dict on it and see what happens. And when I did, I got dictionaries back. Like, what the hell? What the hell is going on here? And so then I said, so Python lets you do introspection. So I said, let's look at what the types of each of these rows are. And when I did that, it said each of these are like SQLalchemy.engine.result.row proxy. I'm like, so basically what Python is doing, what SQL Alchemy is doing is cheating. It makes it look like it's an array of tuples, but really it's an object that when you call dict on it, it knows enough because it knows what the keys are, and it can use them to kind of construct it back in. And we'll talk about like how you go about doing that. And the way you go about doing it is using these things called special methods. So generally, special methods always start with they start and end with double underscores. So if you use any Python at all, the one you've probably seen or familiar with is init. And init is like the new method for a class. And that's underscore, underscore, init, underscore, underscore, and then whatever parameters you want to pass in. So generally, you would never call any of them except for init, where you might call your superclasses init. The other one you might have seen is str, and that stringifies your class, the instance of your class. And they really, there's dozens of these, and they're really like one of the keys to writing not only idiomatic Python, but Python that code that in classes that work like the internal classes and objects and types. So what to call them? They seem to have a lot of names. The documentation calls them special method names. I've also seen them called magic methods. And some people call them double underscore methods, but that's kind of a mouthful, so it gets abbreviated sometimes to Dunder methods. And that's how I came up with the name of the talk. So what are they? So they're sort of odd. They're like their own beasts. So they're a bit like the way interfaces work in Java or roles work in Moose. They're also kind of like virtual methods in C++-ish, or like abstract base classes, or sometimes they're a little bit like overloaded operators. But they're unlike the way they work in a lot of languages. They're really loosely coupled. So they get called if they exist. If they don't exist, they don't get called, and some default action happens. So somebody pointed out to me that they're actually a lot like the way that methods or interfaces work in Go, because Go doesn't really have objects. They have structs with methods that you can kind of attach onto them later on, and so they're a bit like that too, but they're really like their own thing. So let's look at some examples. So a simple example, here we have a name class. It has a first name and a last name. You always have to have self being the first parameter in Python. And then it has self, and then first, and then last. This time self.first to first, and then self.last to last. You construct it using something like that, and then you can print either, if you print name.first, you should get Bruce. If you print name.second, you'll get Wayne, and then let's see. But if you try to just print name itself, you get this, something with a hex string there. Okay, so again, init is like new, and hopefully that's pretty straightforward. So if we wanted to print out something other than a big ugly hex string, what you do is you make another method called dunder str, and what that's job is do is take whatever is in your class and turn it into a string in whatever way you want to do it. And in this case, I'm going to just that F and the double quote at the beginning, that's one of the new things that's in Python 3 that's not in Python 2. It lets you do string interpolation, variable interpolation inside of a string. So anything that's inside curly braces, inside an F, when you have an F, opening quote, end quote, then anything inside there in curly braces gets interpolated. So I'm just going to make a string with self.first, a space, and then self.last. And now, when I print it out, I get Bruce Wayne. That's nice. So unlike a lot of languages, or most languages, Python actually has two different ways to stringify classes. They have, then it puts out Bruce Wayne. They have another method called repr. The difference, there's a few differences. str is what gets called when you try to print something or treat it as a string. repr is what gets printed out if you're in the Python REPL. I'll show you this in a second. But if you're just in the REPL and you say you have a variable as a class and you say the class is like C and you just type C, it will print out, it will by default print out the repr. It'll call repr and not str. So what that really does is it gives you, what a lot of people do is have repr give a more kind of internal representation of the class, whereas str will be more of a kind of human readable thing. So here I'm just trying to make it look like you would, when you print it out, it looks like what you would call to construct the instance of the class with those parameters in it. So does that make sense? Everyone following along so far? Any questions? Yeah. If you have both, it depends how you're using it. If you try to stringify it, the question is what happens if you have both? If you try to stringify it, then it will use str. And if you can call REPR directly itself, then it will call that. If you're in the REPL, it will call REPR. Okay, so at this point, I'm gonna drop out of the slides for a bit, and then we'll come back to the slides at the end. But I'm gonna just go through a whole bunch of examples now because I think it's easier to kind of see what's going on and kind of play around with it. Okay, so this is, can everyone read that in the back? Is that good? So this is basically the code that I just had, right? So let's hop over here and say Python. Can you read this? Is that good? So because I'm in the REPL and I type n, it prints out, it calls REPR. If I say something like print n, I'll get that. I don't think there's anything else. I mean, I could go in and, let's say that I comment this out. And how do you comment things out here? I forget, but so let's do that again. So here in the REPL, because I don't have it, it just prints out. It prints out the hex string again, but I can say, all right. So, okay, so that's one, everyone kind of following that. So let's make things a little bit more interesting. Where's fake array? All right, okay, so here I have, I wanted to make a class that acts like a Python list. So it's cheating a bit because I'm going to start, where's my cursor? There's my cursor. Okay, so in init, I say self.a is an array. So I'm going to hardwire an array in here for now. I'll have some other examples where I'm not doing that. We'll make it really easy. So double underscore len returns the length of whatever it is that you're calling for. That's one of the standard things. Like everything has a len for it. Strings have lens. Okay, lists have lens, and everything has lens in it. So that's just going to return the length of A. So that's going to return 6 because there's 6 things in there. Get item, that's called if you want to reference something in there. So that's going to say, give me the ith element of the array, and it's going to return that. And then all str and REPR are just stringifying and reperifying it. So. Okay, pretty straightforward. I'm adding these 2 new methods, len and get item. All right, so. Okay, so now I've made an instance of that. If I just type that out, that's what's in there, right? You can read, can everyone read that on the bottom, in the back? Should I raise it up a little bit? Okay. But I can treat it like an array. I can say, let's say I can say len of fa, and it should say 6. I can reference it, I can say fa sub 0, and it's going to give me 3. I can say fa sub -1, and that gives me the last one. I can do slices, fa sub do that. That's because they only go to the 1 after that, so 5, right? I can, and I can sort it. All of this just by adding those 2 methods. So it's kind of cool that you can get all of that just by adding those 2 things, because it knows enough to do everything else. You can treat it as an iterator, so you can say for I in FA, and you can print it all out, 1 item at a time, all by just adding those 2 methods. So that's pretty cool, right? So, any questions on that? All right, so let's look at another example. We don't have that in here. Oh, I'm sorry, I want to do one more example. So in addition to that, we can, there's also another method called, just like there's get item, there's set item. I'll show you that at the end. Okay, so set item, it takes 2 parameters. It takes the position where you want to add it, and then what you want the value to be. I'm sorry? Self.a, you're right, thank you. No dollar symbols.
Where's the semicolon?
But now I can say FA sub 1.
Now you just frummed over it without exiting.
Let's get, damn it. This is the adventure part of it, where let's get that off, because I don't think that was code of conduct appropriate there. Clear. Python.
And the presentation finds a
Oh, those fixes in post-production.
There we go. Yay. Okay, what I wanted to show you before, let's go back to that for a second. So let's remove this again, because that worked, but let's just delete it and see what happens if it's not there. So if you try to do that and you don't have that method, you get a type error that says fake array does not support item assignment. And what you have to do is do what I just did, with do the set item instead. So okay, so let's look at another example. Evens up to. Okay, so what's going on here is I wouldn't have an example where I didn't have a hardwired array. So if you don't have a hardwired array, then you have to do a little bit more work. So here, what I want to have is all the even numbers up to 10. So in my init, I say, well, if placing in something that's negative, I just want to raise a value error because it's a bad parameter. And otherwise, just save what this is. So for that, I have to do some math to figure out what that is. So that's just, I'm going to divide it by 2. And then get item is a little trickier. So if I'm past the length, then I return an index error. Index error means you try to read past the end of an array. Otherwise, I'm going to return I times 2. And if I print this out, now, so the first time I tried to print it out, because I don't have an str method here, I just got this. But it did let me iterate over it, so I can go, and what happens is it prints 0, and then 2, and then 4, and then 6, and 8, and then 10, and then once it gets 10, then it's beyond there, it raises an index error, and then the index error says stop the iteration. So that's how you stop an iteration if you don't have an array that's already built in. So it said 0, 2, 4, 6, 8, 10. Okay, so that's how you deal with arrays. For dictionaries, it's a little bit more work. So let's look at test. So we still haven't talked about how we do the thing that SQL Alchemy was doing, but we'll get a little bit closer with this. So the way I'm going to fake this dictionary is actually I'm going to make a dictionary, but I'm going to make it from keys and values. So my keys are 3 animals, and these are how many legs they have. I'm going to make a dictionary by zipping the 2 of them together. So we already saw these examples before. So the length, I can take the length of either one of these, so that gives me that. To get an individual item, it turns out that it's still, is that example? Yeah, what I want to do here is I'm still going to just get the ith item, but I want to get the ith key and the ith value, both. And so that's what that's going to do. And because when I print out that, I'm going to get keys and values, and a list of keys and values, I can turn that into a dict, and I'll get it out that way. So, and then str is just, I think what str is doing here is just trying to make it look like it's a list of tuples. And right, so this, if you return more than one thing from a function, it returns it as a tuple. So that's what that does. And then, well, let's just run this and see what it does. Is there a test dict? Okay, so what it printed out here was the first time I printed out what the class was. And when it does that, it just prints out, what did it print out? Right. I think here I just wanted to print out the values of it because that's what it's doing here. All I'm doing is getting the values. So that's why I have 4, 6, 8. But when it turns into a dictionary, because as it goes through and gets each one of the items, it has a tuple and it can turn that into a dictionary. And then I think at the end I iterated over it just to prove that. So when I iterate over it, I get dog 4, ant 6, spider 8. So maybe I should have had this example after that one. But does that make sense what's going on here? So what I'm returning, for each one of the things I return a tuple of the key and the value, and then I can use that to turn it in thing. But when I print it out, yeah, I think that was the example I wanted to say, that when I print it out, I just get the values. But yeah, I was trying to have an example where you do 2 different things, and you could, sometimes you can get just the values, and sometimes you get the keys and the values, and you can put them all together and get a dict out of it.
The magic is in the get item.
The magic is in the get item, yeah. But it turns out that that's not the way the SQL Alchemy works. SQL Alchemy uses a feature that I have not seen documented anywhere else. So SQL Alchemy uses this feature. So the thing that I've added here is is keys. So if you have a method called keys, not dunder keys, but just keys, and you call dict on it, it will call the keys thing and get the keys that way, and then use each one of those keys and iterate over it and get the corresponding value for it. So I think, what happens when I run this is static keys. Yeah. Right, so let's look at what I'm doing here. So I create an instance of the class, and then I print it out. And the first time and let's look and get, why is that? What did it call? Didn't it call this? Maybe I didn't save it. There we go. So, sorry, this example isn't going quite the way I was hoping. Let's comment on that one. Okay, this is what happened. So, let's just ignore that. Okay, and save that and run it again. Okay, so what happened here was, when the first time I printed it out as just the thing itself, it just calls get item for the first one and the second one and the third one. So when so I'm passing in what gets passed in is k, and so it passes in here. It passes in 0, 1, and 2, and so I get a list of tuples out of it like that, dog, cat, like that. But the second time, when I call dict on it, it calls keys first. Let's run that again. Damn it, what did you do? Did you put a tab in here? It did. This is what I get for trying to use a new editor. There we go. Right. So it calls keys, and then keys returns what the keys are in there, and then it calls get item again, but now instead of passing in 1, 2, and 3, it's passing in dog and whatever the other animals were, ant and spider. So get item is used both to return as an array where you get 1, 2, 3, or it will pass in the key and you return the corresponding value for it. So it can be used either way. Get item is used for both of those. So that's actually what SQL Alchemy is doing for its magic. So when you print it out, it just gets the values, but when you call dict on it, it calls keys. Keys says what the columns you were looking for, and then it uses that to turn it into a dictionary. What do I have? I have like 10 minutes left.
You have 7 minutes left.
I have 7 minutes left. So let's, yeah. So let's go through, I'm going to skip one. Okay, so we'll go through these quick because I have some other stuff I want to finish up. This is a way to treat your class. So the other examples showed how to treat your class as either a list or a dictionary. This is an example of how to treat your list as like basically a function that you can call as a function. So here I'm using dunder call for that. So this basically says I want to have a die with that many sides in it. So a dn is like I want to have a d6 or a d20 or whatever. So here I'm going to make a d6. I'm going to iterate over it 10 times, and then I'm going to print out what the value is. And then every time it's going to call the call method because I'm saying d6 like that. It's going to call this call method, and it's going to call randint and print something out. So I just want to go through this real quick. dn.p P. And that's what it does. So that's cool, but that's actually not the way that most Python people would do it. They would use iterators instead. The way you do an iterator is you say, well, there's really two steps. You say that there's a dunder iter method, and that just basically says, I want my class to be an iterator. And then there's a next method, a dunder next, and that gets called every time you want to iterate over something. Every time it wants to get the next value, it's going to call dunder next. And then it will return the next value. When it's out of values, it raises stop iteration, and then that's what will cause the iteration to stop. This is kind of like you have to do a little bit more work because you can't rely on it just being an array. Because we're doing everything internally, we have to have some other way of stopping it. So I think here I wanted to have something that's going to do a D6, and I'm going to get 10 values out of it, and then it will stop. I know I'm kind of going fast because I want to finish things up here. And it still works. So anything else I want to run over here? We'll go one more thing real fast. Python also has yield. Yield, like Ruby also has yield. Yield is kind of the same idea as iterators, except they're in regular methods and they're not in, you're not treating the class as an iterator, you're treating a method as an iterator. So it's sort of, when you call yield, the function itself is still running, it returns a value, but it's still running, and when you call it again, it gets the next value. So here I'm just going to yield, I'm going to go through range. This goes from 0, 1, 2, 3, 4, 5, all the way up to 1 minus that. And I want to return 2 times that value. And you could, it basically says I can treat y, this y method, as an iterator, something that I can iterate over and get all the values out of it. So I know I'm going fast for this, but we'll just test. And that works. Okay, I'm going to finish up because I'm starting to run out of time here a little bit. I know I went a little fast at the end. I apologize, but let's. All right, so did you know Python has a manifesto? If you know anyone that's a Python programmer, they've probably told you that they have this thing, you should read the Zen of Python. It will tell you we have this whole list of things that we like to do things, right? One of the things that's there, it's not number one. Number one is beautiful is better than ugly, which the Python people will tell you. Number two is explicit is better than implicit. And I would argue that the way Perl, the way DBI does things is a lot more explicit than the way SQL Alchemy does it, where all this stuff is hiding. Like, they're trying to do magic behind the covers, but it's hard to discover that it works that way. And I think I prefer, give me, like, I want to have a method that returns me the keys and the values and let me deal with it and not just have it be all magic. But I think the point is that you do have to be aware that these things exist if you're working in Python, because like Perl doesn't have anything at all like this, and so you can be pretty confused when things like this happen. So let's review some of the stuff that I went over. Why are we not? Okay, so we talked about str and repr, which are 2 different ways of stringifying your instances of your class. Lens shows how many items are in the class. Get item and set item are for extracting values or for setting values. They can be used both as indexes into an array, or they can be keys into a dictionary. Call lets your class work as an, you can call your class as if it were a function instead of calling methods on it. Iter and next we just went over, and yield is also sort of similar to that. So what if you want to do more, what if you want to find more information about that? And so that is not really super great. There is this page, if you look for just Python data model, you'll find this. It's super long and it's not, it's more of a reference, and it's not the, it's not really like the best way to learn how this all works. There are lists, and it does have all the dunder methods, and there's probably like a couple dozen of them. But they're sort of all scattered throughout it. It's not like you can't just go to the documentation for dict and see all the methods you can call on it. So there are other like third-party pages that have. We'll get to that. I'm almost done. but yeah, those are there too. I should also say that there are also, okay, so let's go. The best book I found is this book called Fluent Python that goes into way, way more detail than I was talking about. I say there's also, if you really want to make classes in Python that work exactly like dictionaries and arrays, if you want to be able to delete things and add things, and then there actually are abstract base classes that you can inherit from, and then you have to instantiate all these different methods and have it work that way. But this book is really, really good. I recommend that. And then that's my last slide. So do you have any questions? Yes?
Except for, not except for, of all the stuff you showed,
Yes.
the Dunderland, significant portions of that we can do with overload, right?
With what?
Use overload.pm. You can do probably the stringifies, the length, the scalar. What's not, I think what's not an overload is probably the iterators. You have to import a mod.
Yeah, Perl, so I have to say I've not, you were asking about overload and how much overlap there is. I haven't actually used overload, so I'm not that familiar with it. Yeah, I don't think that Perl really has anything that's quite like the way iterators are such an intrinsic part of Python.
I think you have to include a module. I think they're area modules, but.
Yeah, right, there may be modules to do it. Yeah, so in the back.
One of the Perl ways to do iterators is to use a function call, in which case you can overload the function call with the behavior of an object.
A function call, did you say?
Like, pretend like the iterator is an anonymous sub, and you just keep calling it until it returns undefined.
Okay, so,
That's a way of doing
yeah.
iterators.
So the comment is that one way to do it in Perl is to have an anonymous function that you keep calling until it returns undef. It doesn't have yield either, and yield is pretty convenient sometimes. Yeah, and it has it has tied variables too, which is sort of similar to these things as well. So that's another way. You can tie arrays to things, then you have to instantiate a bunch of classes. Yes.
Well,
Methods.
when I was looking at it and I was listening to your story, it felt at a certain point almost near to the end that SQL alchemy is giving you some results back you didn't expect it to come back. You want to create now your own dictionary. Would it have been solved if you would have read the manual of SQL alchemy? Would it then have said, by the way, we are returning you a SQL alchemy object rather than a hidden thing?
Yeah, I'm sure. So the question is, isn't this in the documentation somewhere? And I'm sure it's there somewhere. I looked for it and I didn't see it.
Yeah. And the other thing is like the magic happening with SQL alchemy compared to the clarity and the explicitity of Perl. I've been through code bases where I look at stuff and then something happens and I have to figure out why, and then in 5 different subclasses somewhere hidden where oh, that's where it's coming from. So we Perl can screw up as well.
Yeah. Yeah. I mean, those things happen. I mean, these things happen in Python too. I mean, finding the part of the code where keys got called to see that that's what the method was happening took a bit of digging to do that. Yeah. I know one of the issues I've had in Python is, especially with that big stack, is that I think Perl, because maybe there's not a common way of dealing with objects, is that I think the modules that we import tend to be pretty orthogonal to each other, whereas in Python they tend to all kind of build on each other. So it's got good and bad. The good is it's all sort of seamless, but the bad is that, like, which of these things that I'm importing is actually causing this problem? What part of it, which of these like 4 things do I have to look through the documentation for to find like where I want to tweak it to get it to work the way I want? Is this a Python thing? Is it something we wrote? Is it something that's in this class or that class? And I found that to be confusing sometimes. So yeah. So I think I'm out of time. So thank you very much. Hit me up afterwards. Have any more questions?